Let us discuss about the topic logical inference. This is one of the important topic in the unit 1 of discrete mathematics. So let us see what is this logical inference. So in this basically we get a question of this format, or let us see what is this logical inference in this example. So here if you see there are two statements given to us, S1, S2, and followed by a conclusion, some conclusion. Now, what is S1? If you see, statement 1 is, if today is 2nd October, then today is Mahatma Gandhi's birthday. So this is given as first statement as a data to us, or first premise to us. And S2 or statement 2 is, today is not 2nd October. Okay. Now, based on these two premises, based on these two statements given to us, there is an argument given in the down. What is that argument? Therefore, today is not Mahatma Gandhi's birthday. So this statement is an inference given from the given data, given to premise statements. Okay. Now, the task for us is we have to decide whether this inference is a valid inference or invalid inference. Inference means what basically? Inference means conclusion. Okay. So here two statements are given to us, or two premises are given to us, followed by conclusion. Now this conclusion or inference we need to verify, or we need to tell that this is valid and invalid. Okay. So all of you for timing, please pause for a second. Think, answer yourself whether this seems to be valid or invalid. Okay. Okay, think, then of course anyhow we'll discuss now. Okay. Yeah, you can pause for a minute, think whether it seems to be valid or invalid, answer yourself, then we'll discuss. But anyhow, the correct answer is the inference, though it seems to be valid, reasonably, yes, it is strong, reasonably correct argument, but the inference that we are given is logically invalid. Okay. So let us see how to discuss, or how I know that yes, this inference is valid or invalid. So basically there are some standard methods, or some methods are there to say whether the inference is valid or invalid. The first one is standard method that we are going to discuss in this video. And of course, there are four more methods. Let me give the names. Direct method using CP. Third one is indirect method. And the fourth one is automatic theorem proving. Okay. So these are the four methods. Before that, there is a standard method that we are going to discuss now. So using the standard method, we need to verify whether this given conclusion is valid or invalid. So there is a procedure. So let us discuss that now. Yeah. So in this, so what is this logical inference concept? Is it clear? So we'll be getting a set of statements. Statement one, state. Of course, in this exam there are only two statements, but it could be any number of statements. Okay. So the general format of this logical inference is as follows. Okay. So what is the general format? You will be having n statements. It's not one statement, of course. In the earlier example, there are two, but we will be having, in general, it is n statements. Statement 1, statement 2, statement 3, and so on, statement n, followed by a conclusion. So this is general problem format. Now, what we need to do here? So S1, S2, Sn are the given statements, are given premises, and C is the given conclusion based on the given statements. Now, the task for us is we need to say whether that conclusion is valid or invalid. Just we have to say yes or no. Okay. Now, anyhow, earlier example you have seen, so that seems to be valid, but it is invalid. Now let us discuss. Let us discuss the standard method to verify whether the given conclusion is valid or invalid. Okay, yeah. So this is a standard method. So in this, so let us see different steps in this. Step one is first you convert the given English statements to prepositional functions. Like convert the given statements to prepositional functions. So how I convert given English statements to prepositional functions? So that accordingly we need to assume some variables or some prepositions in a given problem. Suppose if we see, yeah, the problem, yeah, if today is 2nd October, then today is Mahatma Gandhi's birthday. That is statement 1. And statement 2 is today is not 2nd October. Statement 2. And the conclusion that is given to us is today, therefore, today is not Mahatma Gandhi's birthday. Now, how I convert these English statements to prepositional functions. So it's very simple. So I assume today is 2nd October as some preposition P. Of course, we can take any name, either P or you can take A, B, C, or you can take X, Y, Z, anything. Okay. So here I'm taking today is 2nd October is preposition P. Then another preposition I have, that is today is Mahatma Gandhi's birthday. Today is Mahatma Gandhi's birthday. I am taking this preposition as Q. Okay. So today is 2nd October. I am assuming as preposition P. Today is Mahatma Gandhi's birthday. I am assuming as preposition Q. And what is the connective involved here? If you see, we have if then. So if then means what? If then means it is implication. So therefore, this English statement by assuming this P and Q. So what is the preposition function? This is nothing but P implies Q. The first statement I can write as P implies Q. Okay. Then second statement is what? Today is not 2nd October. Okay. So, so, so how I write this? I already assume or I already consider today is 2nd October as P. If today is 2nd October, if I assume as P, then today is not 2nd October. Obviously, we will not take a new variable. So it is exactly negation of P, right? So therefore, your second statement is negation of P. So please understand. So what is P? P is today is 2nd October is P. And what is S2? Today is not 2nd October. So they are negation to each other. So therefore, if today is 2nd October is P, then today is not 2nd October will be negation. So therefore, my S2 becomes negation of P. Then what is the conclusion? Conclusion, if you read carefully, today is not Mahatma Gandhi's birthday. So what is expression for this? I already assumed here today is Mahatma Gandhi's birthday as Q. Today is Mahatma Gandhi's birthday as Q. So therefore, this is exactly negation of that. Therefore, this expression is what? Negation of Q. Okay. So this is how we convert the given English statements to prepositional functions. So therefore, the first statement is what? It is P implies Q. Second statement is negation of P. Therefore, what is the conclusion? It is negation of Q. Okay. So this is the first step. Okay. Then once we convert into proportional functions, then what we need to do? So it's very simple. So this is step 1. Just now we discussed P implies Q is the first statement, negation of Q the second statement, and therefore negation of Q. This is the conclusion. Step 2 is get the tautological form. So what is this tautological form? It is very simple. So it is first statement and second statement whole implies conclusion. So what is first statement? P implies Q. So P implies Q. And what is second statement? Negation of P. Whole implies negation of Q. But in general, how I write? So there could be 2 statements, 3 statements, or any number of statements. So in that case, how you write? The tautological form. Suppose let's say this is general form, right? S1, S2, so on, Sn. So in this case, the tautological form is very simple. So take the S1 and connect with the end. Take S2 and take S3 and take S4 and take S5 and so on and Sn. Let us say n statements are given and Sn. Whole implies this whole implies whatever conclusion we have. Whole implies conclusion we write. So this is how we write the tautological form. So very simple. First statement and second statement and so on. Last statement. Whole implies conclusion. Okay. So this is how we write a tautological form. Okay. So that is the reason if you see here, so tautological form in this case is, observe carefully. First statement is P implies Q and the second statement is negation of P. Whole implies the conclusion. Conclusion is negation. So once you get the tautological form, step 3 is very simple. So you construct the truth table for this tautological form. Why? Because it's basically proportional function. So construct the truth table and see whether it is a tautology or not. If there is a tautology, means the given inference is valid. If there is not tautology, it means the given inference is invalid. Anyhow, we already discussed how to construct a truth table for the proportional functions. I am not explaining here, but anyhow, we can see I constructed truth table for the expression for the proportional function. P implies Q and negation of P, whole implies negation of Q. Okay, so how to consider the truth table? Please refer my earlier videos. So if I see here, finally expression, the final proportion function is not tautology. I got 1 0 1 1, not all are not truths, right? So therefore if it is not tautology, means what? The given inference is invalid. Okay, so let me repeat 3 steps. What are the 3 steps? Step 1 is you convert the English statements to proportional functions. Step 2 is once you convert into proportional functions, get the tautological form. How you get the tautological form? Statement 1 and statement 2 and so on. Statement n, whole implies conclusion. Then you get a big proportional function. And for that proportional function, you construct the truth table and see whether there is a tautology or not. If there is a tautology, means the given inference is valid. Otherwise, it is invalid. Now, in this case, after constructing the truth table, we understood that it's not a tautology. So therefore, what is the final answer for us? The given inference is invalid. So by the way, what is the given inference in the problem? What is the given inference? The given inference is today is not Mahatma Gandhi's birthday. So that argument, that inference is invalid. Okay. So this is how, using the standard method, we can say the given inference is valid or invalid.